The traditional classroom is a high-bandwidth environment for attention management. A professor uses physical presence, a raised hand, a shift in tone, or a specific mark on a chalkboard to serve as a live guide, directing cognitive focus exactly where it needs to be. In an online environment, that live human guidance disappears. The student is isolated, facing a screen that offers no spatial cues and no shared gaze to help them navigate the hierarchy of information. Because the instructor is no longer there to point the way, the graphical user interface must step in. The screen itself becomes the mediator, assuming every responsibility the teacher once held in the physical room. Most institutions fail here because they treat digital transition as a mere logistics problem. They focus on moving files, syllabi and long reading lists and all recorded lectures into a web browser without rethinking how they are delivered. This results in a content repository, a digital filing cabinet where students are expected to download information and teach themselves, rather than an active environment designed to facilitate learning. Bridging this gap requires replacing the instructor's physical presence with layers of logic. We have to establish the course's primary objective, map its logical sequence, and finally, design the visual surface where the student actually works. This is the three-tier architectural stack. Without this deliberate engineering, the student's brain is forced to work too hard just to navigate the website. But when these layers are aligned, the interface itself begins to teach. The foundation of the stack is the conceptual model. This layer defines the primary objective, determining what the course is actually for before a single pixel is designed. Every course follows one of two archetypes. It aims to help students either know about a subject or know how to perform a specific task. The domain knowledge archetype focuses on mastery of a field. Its structure is topical, organized around the key concepts, theories, and principles that define a specific academic discipline. The performance skill archetype focuses on competency. Its structure is task-based, organized around the sub-skills and real-world operations required to execute a complex job. When a course claims to teach practical skills but is structured around abstract textbook chapters, the student faces a structural friction that makes the material significantly harder to apply. This friction is often baked into the software itself. Learning management systems frequently force every course into one-size-fits-all templates, usually a chronological list of weeks, regardless of whether the course is about philosophy or financial planning. Relinquishing control to these generic templates compromises the student's journey. The software ends up dictating the pedagogy, often before the first module is even built. To escape the limitations of the software, we move to the middle layer, the structural framework. This layer provides the cohesive logic for the course. It organizes thematic units based on how a student actually learns the material, rather than just how the calendar flows. In a skill-based unit, this structure might follow a specific sequence, starting with supportive information to frame the problem, moving to procedural steps, and ending with whole task practice. Because current online tools are so rigid, designers use iterative abstraction to solve these problems. They step away from the computer and move to whiteboards or paper to map out the logic. The goal is to create wireframes. These are rough sketches used to define the scope and wayfinding of the architecture before software constraints interfere. This hand-drawn sketch for a consumer finance course illustrates a nonlinear structural framework envisioned as a path or game board. Look at the labels: risk management and wealth accumulation. These are constituent tasks reflecting how a professional approaches financial security. Disposable sketches allow a designer to ruthlessly test and discard ways of moving through a course without the technical burden of building a website first. Solving the navigation and logic at this stage is critical. If the wayfinding isn't intuitive on paper, the final digital experience will feel fragmented and confusing. Once the architecture is solved, we reach the top layer, the learner interface. This starts with information design, the invisible backbone of the screen. Information design is the strategic arrangement of content on a single page to minimize cognitive friction and maximize understanding. Digital comprehension is often killed by the wall of words, the long, flat paragraphs common in academic writing, offering no visual hooks for the reader. The antidote is Robert Horne's structured writing. This methodology abandons flat text in favor of chunking, breaking information into discrete, labeled blocks. Here, lesson content is no longer a single block of text. It's divided into easily distinguishable sections. By using bold side labels and bulleted lists, a student perceives the data's hierarchy at a glance, even before reading. This reduces the burden on working memory. By making the structure of the information explicit, we prevent the student from wasting mental energy just trying to parse the page layout. Readability is more than a convenience. It is a pedagogical requirement. Even a perfect course structure fails if the granular information design is illegible. The final component of the interface layer is visual design, the colors, fonts, and aesthetics that define the look and feel of the site. Academics often view aesthetics as decorative, but in a digital environment, visual design serves as a psychological trigger. This triggers what Daniel Kahneman calls System 1, the part of the brain that makes automatic, involuntary judgments. Within seconds of logging in, System 1 assesses the course's value and trustworthiness purely on the visual layout. This is the polished consumer finance wireframe. The board game logic is realized with color and form, lowering anxiety. By making progression explicit with directional arrows and color-coded zones, the interface makes the next step feel obvious. A different aesthetic approach can be seen in this fitness course, which uses clean, simple elegance to achieve the same goal. The clear tab navigation and high-contrast text remove visual noise. This intentional simplicity prevents the student from feeling overwhelmed by the interface. Clean visual design earns the emotional buy-in necessary for a student to engage. When a course site feels professional and organized, students are more likely to commit to the difficult task of learning. When we combine these three layers, the model, the structure, and the interface, we create a system that serves the whole student. This system mediates what designers call the 4 dimensions of learning. This model places the learner at the center of the interface stack. Information architecture serves the cognitive dimension, while intuitive wayfinding supports the behavioral. Professional aesthetics address the emotional dimension, and a well-framed digital space enables the social dimension. This balance is only possible when the design is deliberate. We cannot rely on default software templates to handle the complexities of teaching. The engineering sequence must be respected. Define the conceptual goal, wireframe the structural logic, and only then execute the visual interface. Instructional design in the digital age requires moving past simple content migration. It demands the deliberate engineering of an interface that takes on the burden of the teacher, guiding every step of the learner's journey.